Alright, this is a little bit of a more difficult problem here. Jack and Jill are running in a race. Jack runs at a speed of 7 miles per hour and Jill runs at a speed of 5 miles per hour. Jill starts first and Jack starts 10 minutes later. How long will it be until they are neck and neck? Okay, so that means their distances are going to be the same. That's what neck and neck means. Now, I know we're going off the formula distance equals rate times time, and this is saying that Jill starts first and Jack starts 10 minutes later, so Jill is going to be running for 10 minutes more. So 10 minutes is 1/6 of an hour. We might want to keep everything in terms of hours. 10 minutes is 1/6 because there's 60 minutes in an hour, so 10 over 60 is 1/6. So she's going to be, Jill's running 1/6 of an hour more, so Jill's time is 1/6 of an hour more. So let's make a little table here. Here's where we might want to make a table. So we have Jack, we have Jill, and I like to put a total as well whenever I do these. This will kind of help us get a little organized here. So we'll make our table. And we're going to have rate, time, and distance. So let's see. Jack runs 7 miles per hour. Jill runs 5 miles per hour. And if Jack's time is t, that means Jill's time is t plus 1/6 of an hour. So again, we're going to be in hours here right now. Now that means Jack's distance is 7t, because it's just rate times time, so 7 times t, whereas Jill's distance is going to be 5 times t plus 1/6. Alright, now, we don't really have the fact that they raced a total amount of time. We don't have a total distance. We just want to know when their distances are going to be the same, when they are neck and neck. So Jack is running at 7 miles per hour for t hours. Jill is running at 5 miles per hour, and she's running 10 minutes longer because she started first. So t plus 1/6. So when we solve for t, we're going to get the amount of time that Jack runs right here. So we know that Jack's distance and Jill's distance are the same. So Jack's distance is equal to Jill's distance. So 7t equals 5 times t plus 1/6. That's in hours. Alright, so let's keep working this out. 7t, we're going to distribute this 5 here. 5t plus 5/6. So we'll subtract 5t from both sides. So now we get 2t equals 5/6. And to solve this now, we can do a couple things. We can multiply through by 6 if we wanted to. That'll get rid of the fractions. Or we can just multiply both sides by 1/2. So now we get t equals 5/12. And that's in hours. So 5/12 of an hour. So if we wanted to figure that out in minutes, we would do a conversion here. So 5 hours over 12. Let's convert this to minutes. So we want to cancel out the hours. So basically multiply this by 60 minutes here. So 5 times 60 over 12. So it's basically 5/12 times 60 over 1, and we can actually cancel right here if we wanted to. 1 and 5. So if we do 60 divided by 12, that's 5. So we get 5 times 5 over 1, or 25 over 1. Now we're in minutes here. This answer is going to be in minutes. So 25 minutes. And what this is t. T equals that. So t equals 25 minutes. And t represented Jack's time. So they will be neck and neck. Jack will run 25 minutes. Jill ran for 10 minutes more, so Jill will run for 35 minutes. So you can list either one of those.